Good afternoon, everyone. We're going to get started as people are still joining us. Thank you for joining us for another session of EI Live K-12. We're really glad to have you here with us today. For those of you who are joining us perhaps for the first time, we've been doing these webinars since April 2020. And these are really an opportunity for you, for our audiences to learn a little bit more about the work that is being done across the Columbia Climate School, which was formerly actually, the Earth Institute has been integrated into the Columbia Climate School, which is the first new school at Columbia in the last 25 years. And this includes Lamont-Doherty Earth Observatory, which our speaker is affiliated and appointed at today, Dr. Michael Kaplan, and who is a Lamont research professor at Lamont-Doherty Earth Observatory. He's going to be talking to us about the Little Ice Age, and we hope that from his presentation, you'll get a glimpse into the scope of work that our scientists, particularly at Lamont-Doherty, are engaged in and studying all aspects of our planet. And so if you have questions during the session today, please use the Q&A box. We have disabled the chat for attendees. So if you do have questions for Mike as you go, feel free to type them in the Q&A box. We'll keep an eye on those. And in a little bit, we are going to be also joined by a colleague from NASA GIS, who will also share some resources on this topic that NASA GIS has, particularly for our K-12 audiences of students and educators and parents. So everything is being recorded. So if you need to hop off a bit earlier, don't worry. We will share a version of the recording with everyone within the next couple of days. So Mike, if you want to take it away.
All right, well, thanks. You could hear me okay now?
Yes, perfectly.
Yeah. So, excuse me. So today I'm going to talk about a climate interval or a period in Earth's history called the Little Ice Age. And it's a particularly important problem that many of us study at Lamont-Doherty Earth Observatory. Trying to get cursor. So that the Little Ice Age it occurred roughly from the 14th to the 19th centuries, or 1300 AD to 1900 AD. And Europe and North America, for those of you in New York today, I'm up near White Plains and we've had a few inches of snow already. And this probably lasted much longer into the spring. In general, there was more snow in the winter, more days like today through the year. It's also a very unique period of climate change to study because there's a lot of historical documentation. So I'm a geologist. I'll talk more about what I do in a few minutes. And what I do is I study how climate changes naturally. Climate has varied throughout its history. There have been periods colder than today, warmer than today. And so my particular research and expertise or specialty is looking at how climate changes in natural ways, like natural cycles of climate change before, let's say, the 20th or 21st century. And this period from the 14th century to the 19th century is a particularly interesting period for people like me to study because there's so much historical information that we could compare our scientific data with actually what people did. And I'll talk more about that in a few minutes also. So there's dramatic evidence all over North America and Europe that it was colder. Glaciers, there are paintings that glaciers advanced all over Europe. Towns and buildings were overrun in places compared to previously that had been built during the Middle Ages or even earlier. It's debated why the Vikings left Greenland after they settled. But one idea is that it just got cold and it was too difficult to grow stuff. Sea ice increased around Iceland. There's lots of evidence in North America and Wisconsin that the Great Lakes had a lot more ice than they do today through the winter. I was looking for photographs from the 19th century of larger glaciers. And interestingly, I couldn't find any from the 19th century, even though we know, by the mid 19th century, the people were taking photographs. The earliest ones I could find were about in the early 20th century. And at that point, the Little Ice Age period was coming to an end. Most places were warming up, but glaciers were still bigger. So you could start to see photographs like on the bottom from the Canadian Rockies that still have this glaciers larger than at present, sort of left over from the Little Ice Age period. So this is me in South America. This is in Patagonia, where I've done research for about 20 years, and you can see in the background there are two glaciers. That's where they are today. For those of you who've seen glaciers on TV or in photographs or paintings of Alaska or in the Himalayas or elsewhere, and I'm standing on sediments that the glaciers left behind during what we call the Little Ice Age in Europe. So it was during the 14th and 15th century. So you could see where the glaciers are today, and you could see how much smaller they were compared to where I'm standing, which is where the glacier was about 500 or 600 years ago. So this is one of the things I do, is I go to places like this and figure out when were the glaciers bigger, when were they smaller. The slide on the right is I showed is from the Rhone Glacier in the Alps. You could find paintings like this on the internet very easily. And this is another image on the bottom that I took. And during the Little Ice Age, the glacier covered the whole lake. So that the lake was not there during the 14th to 19th centuries because the glaciers were bigger. And this is actually common in many areas around the world, including in the Rocky Mountains in Colorado, where I've done some research also, that there are lakes today that were covered during this period called the Little Ice Age. This is Glacier National Park in Montana. And Glacier National Park is, well, the name comes from having glaciers, but it's ironic that probably in the next, or by the end of this century, Glacier National Park probably won't have any glaciers. But you can see this is from Google Earth, and you can see there's still some ice at the highest peaks, some permanent ice masses. They're just keeping sort of a glacier shape probably. And this was taken, actually, I don't know what time this was taken, but in the lower right is a picture of me, 1990, when I rode my bike over this road on a bicycle tour. And zooming in, this was July, you could see all the snow in the background. And back in 1990, there was still quite a bit of snow that lasted into the summer. That's me. And you could see from 1990, I had quite a bit more hair than I do today in 2022. This was back when I was in college. And today, probably in July, I'm guessing most years there's a lot less snow than even in 1990. So why is the Little Ice Age important for scientists to study? I'll define the Little Ice Age in a few minutes. And there's a few reasons. One is, excuse me, it's the opposite of what is happening at present and in the future. It's a cold period compared to warming over the next few decades. And this is important for researchers to study. We need to study in the past, not only when the Earth was warmer, but also when it was colder, because we want to know the full range of how climate changes. A second reason is, at least in a few decades ago, perhaps even when I first started to do research on this topic, one argument against humans affecting the climate in the late 20th century was that we were just coming out of this period called the Little Ice Age. So the Little Ice Age lasted up until the end of the 19th century, maybe even in the early 20th century, and perhaps we were just coming out of this cold period, and it wasn't due to human effects. And we'll come back to this question at the very end of the talk, because it's one of the reasons, initially at least, we were studying this important part of Earth's history. And this is the bottom image, is another painting. You could find numerous examples of paintings from the 18th and 17th centuries just showing it was colder. I some of you may have been to Rome. I've been to Rome a few times, and it's hard. I know they get snow. I've heard of it snowing in Rome in the winter, but my guess is it's not as common as it was in the 1700s. A third reason why people like me and other scientists focus on the Little Ice Age and the climate changes is because we can use this period to study how climate affects people and how it's affected civilizations in the past. And this is really important, right? We want to know in the past, when the climate changed, how did it affect people? There's a few examples that are common. We talk about the year without a summer. You could look this up on the internet. Even Wikipedia has a nice write-up. In 1816, there was the Great Frost in England, the Great Winter in France. The bottom is Frozen Lagoon in Venice. I've been to Venice. I've only been in there in the summer when it's usually pretty hot. And so I've never been in there winter, but I don't imagine the canal freezes over much today. This was also in the early 1700s. So another reason why many of us study the Little Ice Age is because it not only can we use it as to see how climate changes from cold periods to warm periods, but we can actually also, because of all this historical information, we can see how it affected people. And one of the reasons is because the Little Ice Age occurred after the invention of the printing press, which was in the 15th century. So there's numerous records, there's diaries, and there's observations, and obviously there were paintings before the printing press. But these are just three examples I was looking at this morning. These books are recent. They were written in the last few decades. The lower right was a New Yorker article in 2019, which was reviewing this book on the upper right. And they all go through some of the documentation of the last few centuries, how climate changed and how it affected society. This book, Nature's Mutiny, I haven't read it. I actually just discovered it this morning when I was preparing the lecture. But apparently the author presents a case that our civilization today has been strongly determined by the climate changes during the Little Ice Age of the last few centuries. And I'll mention some of those changes in today's talk. So some of the incidental events that you could find on the internet, just looking and just for these kinds of things, you can see them on Wikipedia, and they often cite references, or I've found them in some of the books I just showed you that happened over the last few centuries. Livestock dying from freezing a lot more than in the last few decades. Sorry. The big thing is crops failing. There are examples of millions of people starving in Europe through the 16 and 1700s. And now climate may not have been the only factor in that. It could have been due to other issues. But when the climate is not good for farming, obviously that's going to have a big effect on whether people can eat or buy food. There are things called frost fairs on the River Thames where people went out during the winter and had their markets right on the ice. For those of you who might play the violin, the Stradivarius and other violins are particularly, what I've read is they're the best. Some of the best violins were made during the 17 and 1800s, and it may have been related to that the climate was colder, trees took longer to grow, the wood was denser. I remember I think it was about 10 years ago, I saw a good movie with, I think it was Samuel Jackson, who was a collector of these violins. Given the movie covered why they're so unique. One of the books I just mentioned, I mentioned that they because farming, there was so much crop failure. A lot of people moved into cities or migrated to North America and South America. I'll discuss that at the end of the talk. And so it sort of may have had an effect on markets and market economies, and less civilizations being or less people being dependent on farming, more people living in cities, and switch to less agricultural economies around the world in many countries, not everywhere, obviously. I've also read that you could, during the Revolutionary War, you could walk from Staten Island to Manhattan in many of the winters, and the British would, and Washington's troops would often drag sleds across the Hudson River and the New York Harbor, dragging firework during the winters to the troops. And when I was growing up, I grew up in the Bronx. Some of you could tell from my accent. And in the 70s, we had some very cold winters, and the Hudson would get sort of a cover of ice in most winters in the 1970s, but we could never even still think of being able to walk across the Hudson River. Whereas apparently during that little ice age, this was not uncommon. And so I mentioned that one of the things that's unique about this period is we could compare what happened in human history with what happened in natural history or Earth's history. And in some ways, I find this really interesting personally, because I see myself, although I'm a geologist, I see myself in some ways as a historian. I'm a historian of the Earth, if you will, or Earth's history. And so the little ice age or the last few centuries, I can do these interesting comparisons between what's clearly human history, sort of the intersection of human history and Earth's climate history, which is really interesting to me. And this is from one of the books I just showed on a previous slide. And you could see on the left side are the centuries, the 1200, 1300, 1400. And right away, at the beginning of the 14th century in the 1300s, we've all heard of the Black Death or the bubonic plague. Some of us have heard of the Great Famine, you may have learned about in classes. And these things, interestingly, occurred right at the beginning of the Little Ice Age. Whether they're related, we don't know. We may never know if the Black Death or the bubonic plague had a direct relation with the Little Ice Age cold periods, but it certainly could not have helped that the climate was quite bad. There was a lot of malnutrition due to crop failures, etc. And then we go up, I'll point out in the 1800s, there was large scale migration or immigration from parts of Europe to both North America and South America. Some of my ancestors came over from Europe in the late 1800s, perhaps people here or even later. And the 1800s was a particularly cold period in the United Kingdom and other countries, Germany, Prussia, these countries where there were large scale migrations as well. Now, again, I don't know if we'll be able to prove that one led to the other. It could just be a correlation, but it would certainly, the climate didn't help encourage people to stay when there were large scale crop failures. So the term the Little Ice Age, I keep using this term. It was roughly from the 14th century to the 19th century. It was actually first coined by a geologist. I can say it was geologists like myself, Francois Matthay. He was actually a U.S. geologist in the United States. He studied glaciers in Yellowstone National Park and in the Rocky Mountains. And as far as we know, he was the first to use this term Little Ice Age. And the reason he came up with this term is because he was studying where the glaciers changed the way I do. And he noticed they were much bigger from about the 14th century to the 19th century. They weren't as big as the Big Ice Age. So the last ice age, which actually was the focus of my last lecture or talk, occurred, the time varied, but New York City was covered by a glacier or a large ice sheet during the peak of the Big Ice Age. And that was around 20,000 years ago. It started a little earlier than that and lasted a little longer. And what Matthay saw in the Rocky Mountains, and he could see documents in Europe, was that glaciers were nowhere near as big as the Big Ice Age. You know, New York City was not covered by a glacier over the last few centuries, but he noticed in mountain areas like the Rocky Mountains and the Alps, they were a lot larger. And they were probably, that was their largest point since the Big Ice Age. So the Big Ice Age ended maybe 17 or 18,000 years ago, or maybe later around New York or in the Rocky Mountains. And the next time the glaciers were at one of their largest or biggest, most expansive periods was this period during the Little Ice Age. It was the biggest they were since the Big Ice Age. So he called it the Little Ice Age. We've refined a lot of the terminology and what it means, because in 1939, he didn't have a good way to determine the age or know how old these time periods were. The bottom shows various ways we've reconstructed temperature. Many studies over many decades have actually reconstructed how the temperature has changed over the last couple thousand years. Thermometers don't go that far back. Most temperature records only go back a few decades in most parts of the world. I think New York City has one of the longest, actually at the end, perhaps the other person can correct me. New York City has one of the longest temperature records. It does go back to the 1700s in Central Park, as far as I know, but that's very unusual. Most places I've worked, if we can find a temperature record back a few decades, that's unusual. So there are other ways to figure out how the temperature has changed over the last couple thousand years, but this is a plot showing when temperature is warmer than an average and colder than an average. So as you go towards the top, it's warmer. As you go towards the bottom, it's colder. And here's the Little Ice Age, again, from around 1400 or 1300 to around 1900. And you could see all these records show the curves all go towards the bottom of the graph, which means it was generally colder. Right before that, there was a period we call the medieval warm period, or the medieval climate anomaly, and many parts of Europe and North America were probably quite warm as well. And until recently, they were probably as warm as maybe up until the year 2000, 2010. But all the way on the right, you could see the temperature of the last few decades, and you could see that on average, at least in the northern hemisphere, most places are much warmer now than even during the medieval warm period. And actually, this little plot on the top we put together years ago for a paper, just summarizing some of these events that various other studies have defined over the last few decades. So here you see the Little Ice Age. You can see my pointer from about 1300 to 1900. Before that was this period called the medieval warm period, which at least in some areas was generally warmer than the Little Ice Age. And before that, you could see the prior two periods that were both cold and warm. The Rome peak of the Roman Empire was during a relatively warm period as well. So I just thought I'd spend a few minutes on what I do, sort of now tying together some of the things I've mentioned up till now. I'm mainly an observation-based researcher. And what I mean by this is I go to different parts of the Earth, different areas around the globe. This photo is of me in South America. And I obtain observations. I get evidence, or I obtain evidence or data on how glaciers have changed over various periods of Earth's history. So this I've mentioned already. And I'm a geologist, so I use geologic records, we say, or archives, to see how glaciers and climate have changed. So because from 1,000 years ago or even 500 years ago, there's no way to get a temperature record. Instruments didn't even exist. We have to use other ways to know how climate has changed in the past. And so what I do is I look at what glaciers have done, because when it gets colder, in most places, glaciers get larger. And when they get smaller, in most places on Earth, it means it's warmer. So my specialty, or what I focus on, is looking at how the glaciers have changed in geologic history or geologic time. And so I use them to see how climate naturally swings back and forth between warm and cold periods throughout Earth's history. Throughout Earth's history. I do field work. I analyze samples in the lab, also to obtain observations or data to see how glaciers have changed. Now, why are glaciers important to study? Well, up till now, I've been talking about how they've been really important to see changes during this period of the Little Ice Age, and that it was colder. But one of the main reasons is we say that we use the Earth as a natural laboratory to understand how glaciers change. So all of you have seen scientists in laboratories with the laboratory coats, especially over the last couple of years with developing COVID vaccines and other medical progress. People like me say we use the Earth as a natural laboratory. The Earth has carried out a bunch of experiments for us, and we can study these experiments of how climate has changed, how glaciers have changed. So that's one reason people like me have spent much of their career studying glaciers, because the instrumental records or records of temperature and other climate records that you see on the news only go back, I mentioned in most areas, they only go back a few decades. At best, for a place like New York City, they might go back a couple centuries. I mentioned we have to use other ways to do this. And so I use, as I mentioned, glaciers. They also provide a context for what's happening today. For example, we know that climate changes naturally. It always has over Earth's history, and it still is. And so we can study how it changes naturally in order to compare how human effects may be on top of that, or it provides a good example. We can also say, were there other periods in the past that were just as warm as today? And perhaps why was that so naturally? What were the natural changes that would cause glaciers to be as small as today in the past? Glaciers are also important because maybe not in New York City, but in many areas around the Earth, they're extremely important for water resources and the water cycle and hydroelectric power. And this includes in California. If anybody's listening who gets water and melt from snow and glaciers in the Sierra Nevada, this is important for the western side of the United States. It's also important in some areas. My understanding is glaciers carry strong cultural significance for certain countries. Their national identity includes, glaciers being in their catchments. It's also important for tourism. For example, Glacier National Park will not have any glaciers by the end of this century, if not a lot sooner. It's important in Patagonia, where I work. We also say glaciers are, we call them the canary in the coal mine. And what I mean by that is they're one of the first or most obvious indicators that humans are affecting the climate and the climate is warming, and that will have an impact on many of the Earth's biologic systems, the flora and fauna, and also the Earth's physical system. So that just like the miners use the canaries to know when the first signs of there being too much gas in the mine and that they had to leave the mine, we often say glaciers are sort of this first indicator, at least a few decades ago, of changing climate. So those are just some of the reasons many of us, such as myself, study much of their career studying glaciers and how they've changed in Earth's history. I spend less time, I have less expertise on how glaciers are changing now. Again, being a geologist, I look more in the Earth's past. And just to give you an example of two questions that I'm really focused on in my research is in the Southern Hemisphere in South America, and I've worked a lot in New Zealand and I work in Antarctica. Was the Little Ice Age cold period a global climate event? In other words, was it just in Europe and North America that got colder over the last few centuries, or did the whole globe get colder? And we actually, until recently, we were not sure of the answer to that question. And it's an important question that scientists are asking, such as myself, because if it was just an event in the Northern Hemisphere in North America and Europe, and it did not happen in Antarctica or South America, that would mean it must have had a different cause. Whereas if the whole globe was colder for several centuries in the 1700s in South America, at the same time as people were ice skating on the Thames River in London, this would mean whatever caused this Earth to have a cold period, this would allow us to sort of focus in on what could have been the causes. It had to have this global effect, not just in North America and Europe. And also, how do the climate changes differ between these different parts of the globe? And that also helps us understand how big of a climate change this was, which civilizations, which people may have been affected around the Earth, etc., and so on. I'll skip that. So this is just a slide how we get around Patagonia. And the more mountainous remote areas of Patagonia, I've used everything from horses to boats. That's me in a little boat crossing a river before the wind picked up. We get stuck in snowstorms like is happening today up here in Westchester County. Lots of boats. We do have some nice weather days. We use Photoshop to make this image look like we're all in the Wild West of the 1800s. That's me in the upper right. And these are colleagues that I work with in Chile and Argentina. So we pretty much use everywhere we can to get around to study the glaciers. So this is an example in South America of my research that I did for about 10 years. And this is a glacier called the Uppsala Glacier. So these are the Andes Mountains. In the background, you could see the high Andes. There are no volcanoes in this particular area, but the Andes have numerous volcanoes elsewhere that had glaciers. And in front of the Uppsala Glacier, it was named by a Swedish expedition probably in the 1800s. So they named it after a city of Uppsala in Sweden. You can see I drew this blue line, and these numbers represent a time period where the glacier was at the blue line. So I have various ways I can determine when the glacier was much larger, when it put sediment on the landscape. And so along this blue line and within this blue line, there are various boulders and sediments similar to what we find around Central Park, different boulders left by glaciers. And I have a way of determining when the glacier left those boulders, left the sediment on the landscape, when it was much bigger. And these are just the ages, so 600 years, 500 years, 300 years, when the glacier would have left a boulder near that blue line. So I walked along the blue line. I walked in other areas, collected samples of boulders, and in the laboratory at Lamont-Doherty, I can determine when did the glacier put that boulder on the landscape. And these are some of the ages I found out from these boulders. So you can see the ages, 600 years ago, 300 years ago. This is the same time as the Little Ice Age period in Europe and North America. It's roughly from 1400 AD, which is 600 years ago, to about 1700 AD, which is roughly 300 years ago. So the Uppsala Glacier in Patagonia, this is it's at around 50 degrees south latitude in Argentina. So we're in Argentina now, was at this blue line during the peak of what we call the Little Ice Age period, from about the 15th century or 14th century to the 19th century. I drew another blue line and I obtained other ages that are about 1,000 to 2,000 years ago. So the Uppsala Glacier was even bigger 1 to 2,000 years ago and was at the second blue line. So you can see the Uppsala Glacier where it is now. This was actually around the 2000, 2005. It's actually retreated a little bit more since this is from Google Earth, since this image was on Google Earth. I saved this image about almost 15 years ago or 10 years ago. So this is, if you remember this plot from the earlier part of the talk, so we have on the top the last 2,000 years, CE, and the Little Ice Age. One of our scientific questions that many of us were trying to answer for the last few decades is what happened in South America during this period? Did glaciers grow in South America at the same time that glaciers grew in the Rocky Mountains, in the Alps, in Sweden and Norway? And we can answer yes. We now know that this cold period happened all around the earth. It wasn't just in Europe and North America. There are key differences which I can talk about. It's almost another talk I could give. They're not exactly the same. And some of the details when the coldest part of the last few centuries happened varies. Exactly when they ended, when glaciers started to advance and grow varied. But in a general, as a general rule, Argentina and Chile experienced a very cold period at the same time as the Little Ice Age period in Europe. Now, I just thought I'd spend a few minutes talking about the cause of the Little Ice Age. Scientists are confident that one of the key reasons is because there was less energy from the sun. So this is a graph of how much solar irradiance has occurred. And actually, Rosalba could probably talk more about this than I can. And this is on the bottom from 1000 AD to 2000 AD or recent. And you could see that this changes. How much energy we get from the sun has varied. For those of you who've had to take physics in high school, watts per meter squared, this is how much energy is being received at the Earth per meter squared. And you could see that between 1400 AD and 1600 AD, it was quite low. It's the lowest point on this graph. And in many areas, this was the coldest part of the Little Ice Age. Not everywhere. Interestingly, in most parts of Europe, it was actually later in the 1700s and 1800s. And so how much energy we get from the sun, how much heat the Earth receives from the sun, can't explain everything about the Little Ice Age. It can explain some of it. It's also these changes are not large enough to create as much temperature change as we've documented. But it can't be coincidence that we received less energy from the sun between 1400 and 1500 AD in the 15th and 16th centuries, and it was a lot colder on the planet. It just makes sense that those two things would be related. It's not, there must be more going on. It can't just be that. And one idea is that at least in the 1800s and 1700s, there were a lot of volcanic eruptions, and perhaps this caused, as other areas, the two things kind of work together. Less energy from the sun and lots of volcanic eruptions. The two things would cause parts of Europe to be particularly cold in the 1700s and 1800s. I just wanted to end on one of the notes about the effects on civilizations, which I sort of started the talk on. We can also, what's really interesting about this period of Earth's history is we can see how it affected people. And that's, obviously we can't do that millions of years ago before people were around. And as many of you know, there was a huge migration from Europe in the 18th century and 19th centuries. As I said, some of my ancestors came over in the late 19th century. And many of you know, have heard about, or probably learned in history class, that famines through the United Kingdom and Ireland in the 1800s, and famines in Europe. A lot of people from Germany and Prussia and other areas migrated over during this time. Anyway, what I wanted to mention is the first year I went to Argentina was in 2000, and we're driving around Argentina, and I'm reading that some of the towns in Argentina, people still speak Gaelic because they had come over. The grandparents had been alive when they were alive, and they at home they spoke. They didn't speak Spanish, or certainly not English. They would have actually spoken still languages from the old countries. And there was similar in Chile. There's several towns that were large populations from Germany and Prussia had settled in the 1800s, and likewise they spoke German. People I know that I worked with who spoke German could speak German in these towns in Chile that had been really formed in the 1800s when people migrated over from Europe. So this is just wrapping it up now. The Little Ice Age happened again, just to summarize, between about 1300 and 1900 AD. There were some differences where you went around the Earth. There were some differences in South America and New Zealand compared to Europe, but they all generally had a cold. Cold the whole time. Then it had a huge effect on civilizations and people. There were mass migrations to the Americas and famines. Now, I mentioned early in the talk that one reason we study it is to know that at least in the late 20th century, the warming that we experienced and the recession of the glaciers wasn't just due to the end of the Little Ice Age. It's very different than the warming that's happening now. In other words, you can't explain warming at the end of the 20th century, or even now, that we're just coming out of the little ice age. And there's numerous reasons that we know this is not the possibility, but one of them I sort of showed you when the reason I talked about what could be one of the causes of this cold period is, and I mentioned the energy from the sun received is we know, or we conclude that one of the causes of the little ice age was less energy received from the sun. There was probably more volcanism at times, which caused things like the year without a summer. The year without a summer in 1815, 1816, that winter was a huge eruption in a place called Tambora. Some of you may have heard of that. And that probably led to a year or two without a summer. So is volcanism, solar input. Well, these things cannot explain even the warming at the end of the 20th century. They certainly can't explain the warming of the last couple decades. The recent warming is associated with increased greenhouse gases. And there's a few reasons we know that the sun or other things would not be causing this. One is there's warming at night. The sun's not out at night, right? Although you could argue that warming during the day would carry over to the night. The other reason is that if solar input or energy received from the sun increases, the whole atmosphere warms. Well, some of the recent warming is only in the lower part of the atmosphere. Something we call the stratosphere, which is higher up, has actually experienced some cooling because as the energy gets trapped closer to the land masses where the greenhouse gases have increased, it actually causes there's actually cooling above that. Whereas if it was just more energy coming from the sun, you wouldn't see these sorts of patterns or changes. You just see warming throughout. That's my understanding. So thank you. This is my last slide, actually. Went a couple minutes over, and I thought I'd just end on some questions to think about, not to answer today, or some of the questions that I think about. How does climate change affect people today? Does it do it in ways that, or does it affect people today the way it affected people during the little ice age? Is it the same? Can society better deal with droughts today than it did during the little ice age? Maybe if you could think about if a drought happens in one or two places, maybe it could be dealt with because we have better ways to move stuff around. But what happens if many areas have droughts or many areas have heat waves or hurricanes? Would we be able to, as a society, deal with it in a better way than during the little ice age? I like to think so, given we have technology we didn't. Doesn't matter, there are more people living in more areas than there were in the 1400s and 1500s. Anyway, those are just questions for thought. I don't have the answers to them necessarily. Perhaps some of you will someday. Well, thank you to the EI Live and Cassie for organizing this. And I like to say most of my support for my research comes from the National Science Foundation and some also from the Earth Institute that Cassie and I work in. Oh, thank you.
Great, thank you, Mike. And I'm going to turn over to Rosalba from NASA GIS, and who has just shared the links to some of the NASA resources. Mike, if you could let go of screen share, thank you. And Rosalba, we see you. If you could share your screen, that'd be great. And in the meantime, if any of you have questions for Mike about any of the topics he mentioned during his presentation, he's still here, and feel free to use the Q&A box.
Can you hear me?
Yes.
Awesome. And can you see my screen?
Yes.
Okay. Hello, everyone. My name is Rosalba. I help support NASA's Office of STEM Engagement at the Goddard Institute for Space Studies in New York City. And I just want to quickly share with you a few resources for further exploration related to glaciers. So I posted some links in the chat related to these resources. First, I want to share with you about the Global Ice Viewer and images of change, and then also a very cool animation that is called NASA Climate Change, the Rise and Fall of Ice Age Glaciers. So the first one, Global Ice Viewer, is an interactive tool that lets you access these visuals to learn about how climate change has affected glaciers, sea ice, and continental ice sheets worldwide. It also lets you learn about the satellites and the instruments that look at these items. The next one is images of change. So this is a gallery that features images where you can see very, very dramatic changes. Some of them are related to climate change, some are not. The one that I'm showing right now on this screen is the Helheim Glacier melt in Greenland, but there are many other images that you can access, so you can see the before and after and the dates that the images were taken. So a pretty cool website that I recommend for you to explore. And the last one is an animation from NASA's Jet Propulsion Laboratory that lets you kind of turn back your clock 122,000 years and kind of like place a camera above the North and the South poles and see how these massive sheets of ice thickened and thinned over time. So something that may be interesting to you to learn more about glaciers and how they change. And that's it for me. Thank you.
Great, thanks, Rosalba. Okay, so we have one question in the Q&A box from Dennis. And the question is, how does a geologist find a date for historic glacier expansion? There was a slide about chemical data, but Mike, if you would like to weigh in on that, that'd be great.
Yeah, that's a great question. Obviously, that's a key thing, right? That's why when Mattei defined the Little Ice Age, back then the scientists weren't even sure when it occurred. So there's a few ways we do it. Two of the main ways that we figure out when the glaciers were bigger or when they shrunk is when they advance. In some places, like this is common in Switzerland actually, and in other areas, they advance over trees and they kill the trees and they incorporate that wood from the dead trees into their deposits. So then when the glaciers shrink and go back to where they are, like for example now, if you walk around the sediments or deposits left by the glaciers when they were bigger, you can sometimes find these pieces of wood. We call them fossil wood. They're basically fossils, wood fossils. And we can use the technique called carbon-14 dating or radiocarbon dating on these pieces of wood or other pieces. Sometimes we find peats because the glacier actually advanced over a lake and scooped up lake sediments and then mixed them all in with the glacial sediments. So probably the most common way up until recently was something called the carbon-14 or radiocarbon method. Some of you may have heard this method. It's one of the most common methods used in archaeology, for example. But you need to have fossil material to do that. The second way, and some of the chemical data I showed, is a different technique. I mentioned one of the things I do is I determine when boulders or sediments were left behind in the landscape. The same type of boulders you might find in Central Park, just lying about, right? Because they were so big that people didn't move them. And it would take a lot to explain in detail, but basically when something's exposed to the air, it causes chemical changes in the surface of the rock or anything like our skin. As you know, when you're exposed to the sun, you get chemical changes in your skin. Sorry, I can't speak anymore. You get sunburn. Sorry, it's been a long day. And similarly, when a rock or any rock or our skin is exposed to the air, there are chemical changes. And one of the things I do is I can figure out how many chemical changes have occurred. I know how fast these chemical changes occur in the rock and the sediments that the glacier left behind, and I can use that to figure out how long they've been exposed to the air. So basically what I do is I figure out how long sediment or glacier debris or deposits have been when the glacier put them on the landscape,
and how long they've been exposed to the air. And that tells me when the glacier was bigger. So that those two methods, we call it cosmogenic dating or surface exposure dating, where we can measure how long things have been exposed to the air at the surface of the Earth. And I see a second question.
Great. Yeah, if you want to go ahead with the second question, that would be great.
Is there anything in the geologic glacial record that suggests the Atlantic meridional overturning circulation variations, fluctuations correlate to warming, cooling, and if it is a cause or effect relationship? That is one of the questions scientists are still trying to answer. It's not something I'm a specialist in. There is, I wrote a paper many years ago where I did try to match how the Atlantic ocean circulation varied with periods such as the Little Ice Age, and it did seem to be weaker. And so if you remember when I mentioned that changes in the sun's energy can't explain everything, there's not a perfect match, but it could explain. It has to be involved in the explanation of what caused the cold periods and the warm periods, but there has to be other things involved as well. It can't explain everything. And I mentioned volcanoes. Well, one of the other things, if you may have noticed, if you go back to the recording, is I listed ocean circulation. And I was thinking of Atlantic overturning circulation, or what we call Atlantic, not we, well, we as in the scientific community, the experts call Atlantic meridional overturning circulation. And it's for those of you who've heard of the Gulf Stream and North Atlantic and the Gulf Stream and deep water formation in the North Atlantic. This is similar to what's related broadly to Atlantic, what's called Atlantic meridional overturning circulation. So we can see that there are changes in ocean circulation at the same time as warming and cooling on land. But the million-dollar question is if it's a chicken or egg thing. Are they just all changing due to something else? Is the ocean changing and then the land changes? Is the land changing and then the ocean changes? And these are so we know that both things are occurring, but that's and different scientists may give you a different answer depending on how the evidence they're looking at. But there are cases where it's clear that how the ocean circulation changes and how the Gulf Stream changes then causes a climate change. There are other times where it's not clear if one's the lead, or we say the lead or the lag, or the chicken or the egg. So it's a good question, but we can see that there are changes in circulation in the Atlantic Ocean at similar times, but I'm also not as much of an expert in that topic. So perhaps others would have a stronger answer than me, but my understanding is it's a really important question that we're trying to figure out.
Great, thank you, Mike. And I see that's the end of our questions here. And as I mentioned at the beginning of the session, we've recorded this and we'll share this with everyone who signed up, and it'll get posted to our YouTube page. In the chat box, I had also shared with everyone Mike's talk that he did specifically about New York City in the last ice age. He did this talk last June. And if you're interested in the topic, feel free to check out that recording as well. Mike, is there anything else you want to leave our attendees with today? I think it's been fascinating. Thank you so much for your time to share your experience and old photos as well of the changes that you've seen and the importance of why scientists continue to study paleoclimate. Yeah, any parting words?
Thank you for listening, and I hope you learned a few things today. And of course, write us if you have questions. And a lot of the things I presented, you heard it's not good to use Wikipedia for original research, but to learn about the Little Ice Age and solar changes, Wikipedia is a good first source to use. I like to say, So anyway, thank you for coming, and I hope hope you learned something about the little ice age.
Fantastic. Thank you so much, Mike, and thanks, Rosalba, for joining us. Thank you to our viewers, and we hope to see you for a future EI Live K-12 session. All right, have a great rest of your afternoon and evening. Thanks, everyone.
Thank you.
Bye.